All right, we're talking about forward rates. So think about interest rates, and we've talked about where they come from. We start with the nominal risk-free rate. We add risk premiums on top of that, and one of those risk premiums is maturity risk. Well, one of the beautiful things about the yield curve, and so on this yield curve I have the 1-year rates at 5%, the 2-year rates at 5.5%, the 3-year rates at 6%, and the 4-year rates at 7%. The great thing about a yield curve is it's the market's forecast of where rates are going to be. So if you remember, we talked about 3 theories that help explain the yield curve. One is it's upward sloping simply because long-term rates are riskier than short-term, so you get a higher rate of return for longer-term yields. The second had to do with the supply and demand of long and short-term securities, and we're focusing on the third one, which is called the pure expectations theory, which says that the yield curve reflects where the market expects rates to go. So academics like this theory because it's basically saying you and I are going to sell and buy securities in a way that gives us the rate that we deserve for the horizon, the investment horizon that we've taken on. So we're trying to forecast future short-term rates using the yield curve. So that's what we're going to do. So we're going to start with this idea of a simple average. Now, what I want you to remember is that this is an average concept. We're going to use a geometric average, but the average concept is that the long-term rate, the current and future short-term rates average the long-term rate. So think about it. If I'm getting 5.5% over a 2-year window, and I buy a security that's giving me 5% over a 1-year window, then logically I've got to get a higher rate of return in that second year in order for me to be satisfied. Otherwise, I'm just going to buy the 2-year bond because I'm going to get the higher rate. Even if I sell it after the first year, I still come out ahead buying a 2-year 5.5% bond rather than a 1-year 5% bond, unless the second 1-year rate is higher. And that's what we're trying to figure out. What would this rate have to be for us to be indifferent between these 2 1-year bonds and this 1 2-year bond? And you can look at it and see. I don't even have to calculate it for you. You can look at it and see it's got to be what? If I'm going to average 5.5% over a 2-year window, and I'm getting 5% in the first 1 year, then what do I have to have in the second year in order to average 5.5? Well, it's pretty straightforward, right? It's got to be 6. All right, so this is going to be 6. So we're forecasting, that's called a forward rate. We're forecasting a future 1-year rate using a market yield curve. And so this 6 is the market's best guess of where the 1-year rate would be 1 year from today. So if we were going to plot the yield curve 1 year from now, the market is saying 1 year from now, this rate, this would be 1 year from today, is expected to be 6. Now, 1 year from now, that rate could be 7, it could be 5, it could be 4. But this is our best guess right now based on what the Federal Reserve's telling us that they're going to do with rates, based on what we know about inflation and employment, all those economic factors. This is the market's best guess. So what we want to do, though, instead of doing a simple average, which is a very handy concept because it lets you check your answer on the geometric average that we're going to do, we're going to use a geometric concept because it takes compounding into consideration. So here's the idea, and this is in Chapter 3. Remember, Chapter 3 is going to be the biggest chapter on Test 1. And in Chapter 3 it says that, again, on the left, the 1 plus the 2-year rate, 5.5% squared, right, because it's a 2-year period, is going to equal the 1 plus the 1-year rate. And really what I should do is erase this and make this a decimal, right? So 0.055 is equal to 1 plus the 1-year rate, 1.05, times 1 plus the one we're looking. So let's talk about this notation for just a second. This notation says, so on the left of the notation says t is today times 0. I'm going to go today plus 1 period. So if we were going to draw a 2-year timeline, we're going to go from here to here. I'm going to go out to here, and I'm looking for a forward rate that's 1 period long. So this is what I'm trying to find. So the left tells you where you are in time. The right tells you the length of the bond that you're buying, the maturity of the bond that you're buying. So on the left we have 1 plus the 2-year rate squared. On the right we have 1 plus the 1-year rate times the one that we're trying to find, and we're just going to solve for this forward rate that's on the right. So now, I guess I should back up and say that if you think about a simple average, like if we were going to do a simple average, we would say 5% plus 10% plus 7% divided by 3, right, to get a simple average. A geometric average takes compounding into consideration. So it would be 1.05 times 1.11 times 1.07 to the 1/3 power minus 1. So we're using a geometric concept. If rates are similar and not negative and positive and 0, then a simple average and a geometric average are going to be similar, very close. But if they're different, then the geometric average can be quite different from a simple average. So the simple average concept is the one I had up here just a minute ago, where we said, 5.5 equals 5 plus x over 2. And the geometric average says that we're going to put 1 plus the 2-period rate on the left is equal to 1 plus the 1-period rate times the one that we're trying to find. So let's solve. So it's actually pretty straightforward. We're going to take 1.055 squared, and I will do that right now. So 1.055 squared is 1.11303. 1.11303. Now think about what that is. This 11 is this 5.5 twice, and this 303 is the compounding, if you want to think about it that way, right? Because we know that over a 2-year window, this investor's getting more than 5.5% 2 times. They're getting 5.5% 2 times, that's 11, and they're getting some compounding on top of it. That's this little extra piece right here. So that, we're going to divide that. We're going to divide both sides by 1.05. And then we're going to subtract the 1, and that's going to leave us with t plus 1 f1. So if I divide 1.11303 by 1.05, I get 1.06002 minus 1 equals 6.002%. And you know what? That's almost exactly what we found when we did the simple average a second ago, 6%. So this is finding a 1-period rate 1 period from now. Now what we're going to do in the next video is carry this concept a little bit further and find a 1-period rate 2 or 3 periods from now, or what would a 2-year bond look like if I bought it 2 years from now. So that's what's up next.